Let's start with a scenario you've probably lived through. You've got a cable, you try to plug it in, and it doesn't fit. You flip it over, try again, and it still doesn't fit. Now imagine doing a physical action like that, or assembling a complex piece of electronics for 8 hours straight. The human brain simply isn't wired to maintain absolute, unwavering precision over a long shift. Eventually, fatigue sets in, attention drifts, and someone makes a mistake. The standard corporate response to these mistakes is highly predictable. A manager steps in, issues a written warning, tells the employee to pay attention, and adds another layer of manual quality control to double-check the work. In early industrial engineering, this approach of designing rules to fix the person was known as Poka Yoke, which roughly translates to idiot-proofing. The problem with Poka Yoke is that it immediately creates a culture of blame, treating a natural lapse in human concentration as a personal failure. Piling on manual inspections and writing stricter rules doesn't actually solve the root issue. It simply adds expensive, reactive layers to catch defective products right before they leave the building. That realization led an industrial engineer named Shigeo Shingo to radically rethink quality control on the factory floor. While developing the Toyota production system, Shingo shifted the focus away from hunting for defects after they happened and toward designing processes where they couldn't happen at all. He renamed his philosophy Poka Yoke, or mistake-proofing. The guiding principle here is simple. Accept that errors are a completely natural part of being human, but build the physical system so that an error never turns into a defective product. Look at the SIM card in your phone. It has a single, carefully notched corner. That notch corresponds precisely to the shape of the tray, meaning there is exactly one way to insert it. If you try to force it in backward or upside down, it physically rejects the attempt. The design removes the need for you to think about orientation entirely, making the correct path the only available option. This is the essence of Poka Yoke. It stops punishing workers for their humanity and starts protecting them with smarter engineering. In manufacturing, mistake-proofing is broken down into 3 specific tiers of strength. The baseline is level 1, detection. This is a system that allows an error to occur, but immediately flags it so the operator can fix it. This animated diagram illustrates a common detection setup, a weight sensor on a packaging line. If a box rolls across the scale and weighs less than the target amount, the system triggers a flashing red alert, letting the worker know a component is missing inside. It's a helpful safeguard, but it has a massive vulnerability. It still relies on a human being to notice the flashing light, care about the warning, and manually pull the box off the line. To remove that vulnerability, engineers step up to level 2, control. This tier uses physical logic to actively halt a machine or a process until the operator resolves the detected error. A classic application is the 2-hand control on a heavy industrial press. To bring the press down, the operator has to use both hands to press 2 widely spaced buttons at the exact same time. It's a hard stop that ensures their hands are safely out of the crushing zone before the machine will activate. We see this same logic in our kitchens. This diagram shows how a microwave's door sensor interacts with its power circuit. As long as the door is open, the circuit to the magnetron is physically severed.
You can press the start button all day, but the machine will not fire microwaves into the open room. Control systems are highly effective at preventing accidents and stopping defects from moving down the line. However, they achieve this by halting the workflow entirely, which creates bottlenecks. That brings us to the ultimate tier of mistake-proofing, level 3, elimination. This is where engineers rethink the physical geometry of the parts themselves so that making a mistake becomes physically impossible. To see the financial impact of this, consider a typical consumer electronics factory. Let's say a manufacturer is facing a crisis. Thousands of their appliances are failing in the field because workers are accidentally swapping the internal power wires during assembly. This diagram highlights the root cause of the flaw. The assembly requires plugging a blue wire and a brown wire into a motherboard. But both wires use the exact same size connector, and both ports on the board are identical. After wiring 1,000 units, a fatigued worker will inevitably plug the blue wire into the brown, identical slot. Instead of hiring more quality inspectors, an engineer applies level 3 elimination by changing the parts. They source a wider connector for the blue wire and a narrower one for the brown wire, modifying the motherboard ports to match. Now, if a worker tries to plug the blue wire into the wrong port, it simply will not fit. The error rate drops to 0 permanently. Tech companies have applied this exact same logic to consumer cables. The old USB-A connector relies on an internal plastic block to prevent you from inserting it upside down. It's a level 2 control. It stops the error, but it often requires you to fumble and flip the cable before you get it right. The USB-C connector eliminates the possibility of an orientation error entirely. By making the geometry completely symmetrical, there is no wrong way to plug it in. The design solves the problem before it can even happen. The most brilliant Poka Yoke mechanisms rarely involve expensive robotics or complex software. They rely on simple, cheap geometry to guide the user naturally toward the correct action. When a factory successfully implements these mechanisms across its entire production line, it reaches a state Shigeo Shingo called zero quality control. The system itself is so inherently robust that random end-of-the-line inspections become an obsolete practice. Building quality directly into the process eliminates the high costs of scrap, while simultaneously reducing the psychological pressure on the workforce. Operators no longer have to spend 8 hours a day in a state of hypervigilant anxiety, terrified that a single momentary lapse in focus will ruin an entire batch of products. These invisible physical constraints act as a safety net, allowing people to work quickly and confidently while protecting millions of dollars of machinery from inevitable human fatigue. We even rely on this safety net when we fuel our cars. This diagram shows why you rarely hear about someone accidentally filling a standard petrol car with diesel fuel. The nozzle on a diesel pump is physically thicker than the opening of a standard unleaded gas tank, creating a mechanical barrier against a catastrophic engine mistake. At its core, Poka Yoke is an exercise in empathy. It recognizes that humans are brilliant, creative, and inherently imperfect, and it chooses to perfect the process rather than demand the impossible of the person.